Learners. My name is Mr. Poch Lola once again. Your teacher on this platform. We just completed a topic in Form 3 chemistry, which is called experimental techniques. And I thought that it would be wise to give you some questions to practice to show your understanding of the topic. All right, so what you need to do is just follow the link below and download this PDF, and then you practice the questions, answer the questions, answer as many questions as you can. I'll be delighted and I'll appreciate if you can share with me the answers to the questions. And where you are stuck, maybe you're not sure, you can ask me questions using the numbers shown here. All right, so you meet questions like what is a chemical waste, which we also discussed very well and to a large extent. So define the term chemical waste. Discuss safe ways of disposing chemical waste in the lab. By the way, these are exam based questions. So you may meet some of these questions in your exams, or you can see them in different papers, mock papers from different schools. Okay? So discuss safe ways of chemical waste in the lab. Remember that there are basically 3, if not 4 ways of disposing of waste, namely use of waste bins, all right, use of designated protected containers, recycling, and incineration. These are the 4 ways we discussed in the lessons. If you missed that lesson, please go back to the videos on this channel and then learn. Number 3, a chemical waste can be regarded as a hazard if it meets certain criteria. What is the criteria? What makes a chemical waste hazardous or having the potential to cause harm? Hazard is anything that has potential to cause harm to you, the person, the student, or the teacher, or anyone working in the lab, as well as harm to the environment. All right? So, what characteristics should such a chemical waste have? So think loudly on this one. We are looking at flammability. A substance that is flammable is considered to be a hazard. Corrosivity. A chemical waste that is corrosive is considered to be a hazard. Or very reactive chemicals thought to be dangerous, as well as toxic or poisonous. Being toxic means having the potential to kill if ingested, if you ingest the chemical or swallow the chemical by any means. All right, so this is called criteria for hazard. A chemical is said to be hazard if it has these 4 characteristics. How do you dispose a broken glass? All right, so I want you to say how you can dispose of. Suppose you broke glass accidentally in your lab. How would you dispose of the bits of the glass from the broken beaker. Okay, how do you dispose a broken beaker? Number 5, why is it not advisable to mix solid waste with wet waste in the same container? Waste container. Think about chemical reactions, right? And what would happen if there is a chemical reaction between solid waste and wet waste, right? So think about that and the products that would be formed in terms of how they would affect you, the student, and anyone working in the lab. I want you to think about why it is important to identify the right apparatus and the techniques before you carry out a scientific investigation. Why is it important to assemble before you do this? It has to do with scientific investigation. Okay, so you're saying, why is it important to assemble, to identify the right apparatus and the right techniques or methods before you carry out an experiment? Why? So think about what impact or effect this would have on the quality of results. Okay. Number 7, define a pure substance. Define a pure substance. What is a pure substance? When we say that a substance is pure, what do we mean? What do we mean when we say substance is pure? In the topic, we also looked at the criteria for purity, and we said that there are 3 experiments that can be done to show that a substance is pure. So how will you use melting point, boiling point, and paper chromatography to determine the purity of a substance? I want you to tell me. Okay, so make a write-up and share with me. Describe an experiment that would be carried out, you would carry out to find out if a given clear liquid is water. We looked at, remember we looked at 2 ways to determine if a substance is water or not, or to determine if a substance contains water or not. 1, by using anhydrous copper sulfate, CuS4. So I want you to explain how we would use anhydrous copper sulfate to tell that a given substance is water, given liquid is water, and also using cobalt chloride. So how would you use cobalt chloride to determine the purity? To determine that the given substance is water. All right. So download the PDF from the link that I've shared, and then you answer the questions and share with me the answers. What are relative flow? Number 10. What are relative flow values? In short, written as RF. What are relative flow values? I want you to give definition of relative flow values using what you learned in this video, in the lessons. What are relative flow values? How would you ascertain that a given sample of ink is pure? How can you tell that a given sample of ink is pure ink or contains some impurities? This has to do with chromatography again. So I want you to just make a small write-up in terms of procedure, step by step, how you can tell that a given sample of ink is pure, was pure. Number 12, suppose that you discovered 4 dropper bottles containing clear, colorless liquids in your school laboratory, and you find the following labels. You have barium, chloride Cl minus, silver, sulfate, by the way, I don't know, sulfate, this is supposed to be sulfate, SuLPH. All right. So suppose you find these labels, okay? But unfortunately, the labels have not been attached to the bottles. So you decide to number the bottles as 1, 2, 3, and 4. Then you mix the solutions in pairs. Now, 3 combinations of these will give white precipitates. Remember that when you are determining or testing a solution for the presence of certain ions, you look for formation of precipitates and their colors. Okay, so 3 of them will give you white precipitate. Combining 1 and 2, 1 and 4, and 2 and 3 will produce white precipitate. So I want you to say which ion does each bottle contain. So make use of what you've learned to come up with the solutions to this question. All right. Number 13. Describe a simple test for each of the following gases. In the lessons, we discussed tests for gases. All right, we discussed tests for gases. We discussed tests for hydrogen, how you can test for hydrogen, how you can test for chlorine gas. Hydrogen is H2. How you can test for chlorine, Cl2. How you can test for oxygen, O2. How you can test for nitrogen. I don't think we discussed nitrogen. This is just a bonus question for you to find out. But I recall having talked about ammonia, NH3. All right, so make an outline of the procedures involved. I emphasized in the lessons that when you are asked to describe a simple test, the description should have 2 parts. One, should explain what to do, what you need to do, and the expected results. You have usually have two marks, so each part is worth a mark. Okay, for example, I will give you an example. In order to test for hydrogen gas, all you have to do is bring a burning splint, okay, near the mouth or the opening of the gas jar. That's what you would do. And then the expected result would be production of a pop sound. You hear a pop sound, that's the expected result. So you have 2 marks there. So for each gas, I want you to do the same. You tell me what you need to do, and then the results that you would have. All right? And please share your answers. Once again, my name is Mr. Paul Chilola, your teacher on this platform. Okay. I'm delighted to teach you, and the idea is to have you pass your MSc exams. All right, number 14, a mixture contains an insoluble compound and a soluble compound. The mixture is separated by adding hot water and then filtered. This produces a white precipitate solid, a white solid A and a green solution B. The white solid and the green solution were tested to find out what they were. The table shows the tests used and results. So the table is right here, down here. Okay, so we have solid A. Solid A. The test carried out on solid A involves a flame test, which is heating and observing the color of the flame. Then the flame that was produced was brick red. When the dilute hydrochloric acid was added, bubbles were seen. And the gas was tested, and it was found to be carbon dioxide. So using this information, I want you to identify the cation A. So cation, remember, cation is a positive ion. So the gas produced is carbon dioxide. I want you to state the test for carbon dioxide and the result of this test. All right, so please share the answers with me. And then you have a solid or greeny gas. Test on the green solution, B. Sodium hydroxide solution is added and a green precipitate is formed. Dilute nitric acid is added and there's no change in both cases. Then barium chloride solution is added, a white precipitate is formed. Then dilute hydrochloric acid is added again, no change. I want you to state the formula of the cation B. Remember, it produces green precipitate. What could be B? What could be the identity of B? All right, and then state the name of the green precipitate. So first you write the name, the formula, then you state the name of the precipitate. Then identify the anion in B. The anion here is a negative ion. I want you to say what it is. Then is it a sulfate? Is it a chloride? Is it a chloride? Is it a sulfate? Is it what is it? A fluorine or whatever it is? So you have to tell me. And the last question is, the pie chart shows approximate percentages of volume of gases in dry air. Which part of the pie chart, XYZ, represents nitrogen? Explain your answer. Okay, so just look at the chart and then look at the proportions of the pie chart. Each proportion represents a gas, percentage of gas. Okay, so just to recall, the most abundant gas in the air is what gas? So answer that. What is the proportion, the approximate percentage of oxygen in dry air? You also have to, based on what you already know, to say that. What is the test for oxygen gas? You state that. Name the gas in the dry air that is formed by the complete combustion of. So this is just an applied question. Combustion is burning. So when you have CH4, which is methane, reacting with oxygen, What is the product? All right, so once again, I'm looking forward to receiving responses from these questions. Please don't hesitate to share with me the answers. All right, so in the absence of questions, I wish you all the best and expecting to see you later. Like I said, I'm sharing this file with you. So I'll post a link, the Black Slides link, so that you can follow it and download the file. Once again, consider subscribing to the channel, and also inform your friends that they can come and learn on this channel entirely for free. So invite as many friends as possible to subscribe. And I thank you a lot for subscribing already. Those who have subscribed, thank you very much. We started very, very slowly, but we are growing. 222 subscribers now. It's a big number for me. I don't take it for granted. The idea is to educate as many people as possible in the sciences, physics and chemistry. All right, so thank you very much once again. Bye.